Welcome to T3, day 14 of calculus. We're going to talk about antiderivatives today. First, remember these three properties from yesterday. First is that you can break apart and put together integrals as long as that middle number is the same, the b value stays the same. You can factor out a constant, you can put it back in, you can move it around, you can pull it out, just that it's only if it's a constant, like 7 or 8, 12 pi. And then the other part is if you have the integral of two functions, you can break it apart into two separate integrals. All these things will be super helpful when evaluating. So let's say we're given this position function. We know it's position because it's s of t, where t is in seconds and s of t is in feet. Positive is north and negative is south. What does s of 2 mean? Well, you're plugging just 2 into this function. So 2 times 2 squared plus 4 times 2 plus 5. That's going to be 8 times 2, so 4 times 2 is 8 plus 8 plus 5, 16, 21. So that means at time 2, the person or object, I guess we could say, it doesn't specify the object, is 21 feet north. 21 feet north. Find v of t. Well, we know that v of t is the velocity function, which is the derivative of position. So we're going to do the derivative of this function. We take the 2 and bring it to the front, so it's going to be 4t plus 4 is v of t. So we know that's v of t right there. We did that because looked at there, brought the 2 to the front and dropped the power by 1. And then the derivative of 4t is just 4. And the derivative of 5 is just a constant. So we know v of t is 4t plus 4. So this right here is the area under the curve of velocity. So that's going to be net, we've done this before, net change in position. So if we wanted to do that, we're looking at the integral from 0 to 2 of, well, we know v of t is 4t plus 4 dt. It's the area under that curve. To interpret it, it's going to be the net change in position. So we haven't evaluated it because we don't know what the number is, but this number will represent the net change in position. So what are the 4 ways we can actually evaluate this? Well, the first way is we could use the fundamental theorem. We could use the fundamental theorem. And that tells us that the integral from a to b of v of t dt is going to be equal to the position at b minus the position at, can't write that properly, can I? The position at a. Well, we know, because it was given to us, what the position is, 2t squared plus 4t plus 5. And we figured out that s of 2 is 21. S of 2 is 21. So in this case, we're looking at 0 to 2 of v of t dt is going to be equal to s of 2 minus s of 0. And remember that s of t, as given above, was 2t squared plus 4t plus 5. And we know that s of 2 is 21. That's the first thing we did. So we can plug that in right there, and we end up with 21 minus, well, what is s of 0? Plug 0 into here, and you're just left with 5. So we end up with 16. So that tells us that the net change in position is 16 feet north. So what's the second way of calculating 0 to 2 of 4t plus 4 dt? It's going to be the manual method of just actually finding the area manually. Well, 4t plus 4, what does that look like? Well, that's just, we don't have to be perfect here. 4t plus 4, we're going from 0 to 2. Let's call that 2 right there. So all we're looking for is, what is this area right here? What is that area right there? I'm going to do the really cool shading right there. Yay, it's kind of nice. So we need to find out what that area is. You can count blocks, you can do it a bunch of different ways. Let's find out what that intersection point is. Well, the x value is 2. Plug in 2 into there and get 8 plus 4 is 12. So how do you find the area there? Well, you could do it as, you could find the area of that block right there. It's going to be 4. So if this is 2 and this is 4, remember it's not to scale, 2 times 4 is 8 right there. Then you have a triangle right there. 1/2, what's the base? 2. That one's 8 right there. And what's the height? Well, you're going from 4 to 12. You're going from 4 to 12, so it's a height of 8. So that's going to be 16 over 2. 16 over, which is 8. So you have 8, and 8 is 16. So you just found out that the area right here, this whole area, is 16. And remember, it's not to scale. This should be a lot steeper. That's why it doesn't really look like that's 8, but it's 16, which does match what we have right here. So we got the same answer. So the second method was to do it manually, find the area manually of that shape. And because it was a straight polygon, straight edge polygon, well, all polygons are straight edges, because the shape has straight edges, we can find the area in a relatively straightforward manner. Our third method is just going to be to do math 9, which is the fn int function. And some of you, it's going to look like not fin, but fn int. And as long as you have the function typed in as y1, you're going to have y1, comma x, comma 0, comma 2. Or it'll look literally like this, 0 to 2 of y1 dx, and you will get an answer of 16. Now another method, which is really fun, is actually see what it looks like get filled in on your calculator. So what you can do is, as long as y1 is typed in your calculator as our 4t plus 4 right there, as 4t plus 4. So as long as y1 is 4t plus 4, you can graph it on your calculator. It looks like this. I've set the window so it looks kind of nice. I mean, the window is set to be 0 to 3 and 0 to 20 for x and y. But you can do this thing second calc and then hit 7 right here. And what it'll do is ask you for a lower limit. What do we want the lower limit of integration to be? So you can either move it around to the cursor or you can just type the number. So we want to go from 0. So I hit 0 and hit enter. What do I want the upper limit to be? 2. Enter. And look what it does. It fills it in and then it tells you it's 16. That's pretty cool. So it shows you what it looks like filled in. It's kind of cool. It's not 100% necessary, but I like it. Next, remember the fundamental theorem of calculus. I've only asked you to write this down and to talk about it a bunch of times, so please remember the fundamental theorem of calculus. So let's do these now indefinite integrals without being told what the antiderivative is. Indefinite means there's no limits of integration, meaning we're looking for what function has a derivative of 2x. What function can you take the derivative of? What function has a derivative of 2x? That's what we're looking for. So you think about it, well, if it's the first power, now it has to be the second power, but hey, what's the derivative of x squared? Well, it is 2x. Keep in mind, though, there could be a constant on this. So the indefinite integral of 2x is x squared plus c. Let's change it up just a little bit. What about the indefinite integral of 4x? Well, it's going to be x squared, but if you do the derivative, you just get 2x. So you're going to need to park a 2 down below, because when you take the derivative of this, you end up with 4x, and then there's always plus the constant. So now you have something that's longer, but it really is just 3 all done together. So let's undo that one right there. The derivative of what is 1? Well, that's x, because the derivative of x is 1. The derivative of what is 2x? Well, we just did that. That's x squared. So we've had 2 of them. Now the derivative, wow, what about that one? Well, it's x squared here, so it has to be 1 power higher, x cubed. Oh wait, what's the derivative of x cubed? The 3 drops to the front. Oh, that's what we want it to be. So the answer to this is x cubed plus x squared plus x plus c. That constant always has to be there. Yes, you will get a point off if you don't put that in. So let's generalize this a little bit. Let's just make up some numbers here. Let's say it was 7x to the 5th, and I asked you what the indefinite integral of that was. Well, you know it's going to be x to the 6th, but when you drop the 6 to the front, you want it to go away, and you want the 7 to be there. You just want 7 to be there when you drop 6 to the front. So you know that 7 needs to be there, but when 6 gets dropped to the front, it gets canceled, so you know it's going to be, oh, 7 over 6 plus that. So the 5 turns into a 6, but you need to get rid of it, so you put the 6 in the denominator, but you want that 7 to be there, so you put the 7 up there. The way you generalize this is like this. This is the one you should memorize. It's super helpful. So when you do the derivative here, you drop the n plus 1 to the front, and it cancels with this n plus 1, leaving you with just a. So this is the generalized way. So if you do it out, it just gets a little repetitive, but it goes real quick once you practice it. So we know the antiderivative of 1 is x. Well, what about this one? It's going to be x squared, but there's an 8 in front. So if you drop a 2 to the front, because the 2 is going to be there, 2 times what is 8? Oh, it's going to be 4. What about this one? It's going to be x cubed, but that 2 needs to be up front, but you want that 3 to go below it because you want to cancel with that 3. What about this one? It's going to be x to the 4th, and that 4 is going to be below, and that 5 stays. And for here, you have x to the 5th, and you want that 5 to go away, but you want that 3 to stay. So it gets really repetitive in a way, but it gets really straightforward. So let's do that out. So here, you increase the power by 1, but then put that same number below, but that 3 stays the same. The 3 stays the same. And then what happens here? The minus stays the same. It's x to the 4th. That 4th goes away, but the 5 stays there. What about here? It's plus x cubed. That 3 goes away, but you want the 2. It's kind of sloppy writing. Let me clean that up. It should be, these are in parentheses here. So it's going to be 2 over 3 x cubed. And then what's this one? X squared. But you want that 2 there, and you want the 8 to be there. That'll simplify to 4. And this is just plus x plus c. That is the indefinite integral. So now you can do indefinite integrals without a calculator. Because to do this one, you would need to plug 5 into the antiderivative of that. Now you know how to find it. Well, this is going to be, well, what's the antiderivative of this? Well, 2x, you know, is x squared. The derivative of x squared is 2x. And what's the antiderivative of 3x squared? Well, that's x cubed. Because the derivative of x cubed is 3x squared. And you're evaluating this from 0 to 5. That's what that bar means, from 0 to 5. So that means you're going to do 5 cubed plus 5 squared minus 0 cubed plus 0 squared. This is the f of b minus f of a. That's 125 minus 25 minus 0, so the answer is 100. Well, that's pretty cool. And you'll notice I made that a minus. It should be a plus. That should be a plus right there. So 125 plus 125 plus 25 is 150. So over here, we need to undo this function right here. What is that going to be? Well, that's just going to be, oh, x to the 4th. That 2 stays there, but that 4 goes below. Plus, what's the antiderivative of x? Well, it's going to be x squared, but there's no, the 2 gets canceled, and it's just a 1 right there. You can test this out, because what's the derivative of 1/2 x squared? Well, that's just going to be x. And what's the derivative of this? Well, the 4 drops to the front. It cancels with the 4, leaving you with 2x cubed. So that's the antiderivative. So now you know you're going to have to evaluate, and I'm going to simplify here. It's 1/2 x to the 4th plus 1/2 x squared, and you're evaluating it from 2 to 4. From 2 to 4. That means you plug in 4 into this, and then you subtract what happens when you plug in 2 into that. If you plug in 4 and then plug in the 2 and do the subtraction, you should get 126. You should get 126. You could check this on your calculator using one of the calculator using any of the 4 methods above. So the last question is find the area between the x-axis and that curve. You could draw a picture of this, 2x squared plus 4. It's going to look like a parabola like that. It's going to be 4. And you're going from 0 all the way to 4. So what's that integral going to be? 0 to 4. And the upper function is 2x squared plus 4. And it goes all the way to the x-axis, so it's just minus 0. So you don't have to write the minus 0. So you're doing this area right there. If you wanted to write out the full integral, it would be minus 0, because that is the x-axis, the y value. So now you need to do the antiderivative of this right here. Well, the antiderivative of 4 is just going to be 4x. And the antiderivative here is going to be 2/3 x cubed. That is your antiderivative. And you're doing it from 0 to 4. So if you do that out, what does that mean you have to do? First you plug in 4. So if you plug in 4 into this, you get 2/3 times 4 cubed plus 4 times 4. You do that first. And you subtract what you get when you plug in 0. And a lot of the time when you plug in 0, you're going to get 0. And that is the case right here. This is just 0. And when you do this out, you end up with 2 times 64 over 3 plus 16. 2 times 64 is 128 over 3 plus 16. You don't really need to go any further than that. That's fine. So that would be your area under the curve.